Hello, welcome to today's class. In today's class, I'll be solving likely mathematics UTME questions for the year 2026. So I have about 100 likely mathematics questions that I'll be solving throughout the videos that I'll be releasing. So for this particular class, I'll be solving the first 10 questions, and then for the other videos that we'll be releasing after this particular one, we'll solve the remaining 90 questions. So it's very important that you subscribe to this YouTube channel so that we can be aware when we release the next set of videos. So let's get right into it. For the first question, we are asked to find the value of x if log x squared plus log x raised to the power of 6 plus log 1 over x raised to the power of 5 plus log x raised to the power of 17 equals to 20. How do we solve this particular question? So for this question, we have to apply logarithm rules. But first, you will observe that in this particular logarithm question, there are no bases. Now, whenever you are given any question under logarithm and there are no bases, just automatically know that they are all in base 10. But that's not the first thing at the moment. So let's quickly look at the rule that we can apply to this. So you remember the multiplication rule, or we also call it the addition law, where we have log x base n plus log y base n. If I have a question like this, how do I solve it? That is, if I have common bases, base n, and I have logarithm, and there's a positive sign in the middle, the law basically states that pick one of the logarithm to the base of n, right? And then you would multiply these two upper values. So that will be what? X times y. So if you compare it to this question that we have on the board, we could actually do that because logarithm is common, logarithm is common, logarithm is common, logarithm is common. Like I said earlier, the bases are common bases because they are not written. It's in base 10. It's common. Is that understood? So we would apply this particular multiplication law in this particular question. So what we would have is going to look like this. Logarithm, you open a big bracket because you are multiplying. You would have x squared multiplied by x raised to the power of 6 multiplied by 1 over x raised to the power of 5 multiplied by x raised to the power of 17. You close the bracket, equals to 20. Now you can simplify this in whichever way you want. You can use indices. You can also cut, right? Because you have x squared here, x raised to the power 6 here. You can divide, but let's do it in the indices way. So what we would have is going to be log into x squared times x raised to the power of 6 times x raised to the power of. If you look at this, there's a rule in indices that is called rule of negative index. It means that this 1 over, I can write this as a negative sign in the index of x, and that is minus 5. So what I would have is times x to the power of 17 equals to what? 20. So to simplify that, we would have log x. Now indices rule states that common bases, pick one of the common base, and then because of multiplication, add the powers together. So that will give us what? 2 plus 6 plus into minus 5 plus 17. Then I can equate it to 20. So moving on from there, we'll have log x. Now let's sum this together. We have 2 plus 6 is 8. 8 minus 5 will give us 3. Then 3 plus 17 will give us what? 20. So we have x raised to the power 20 equals to 20. So from here, we should be getting to our answer so that we can find the value of x. So let's do that up here. Now we have log x raised to the power of 20 equals to 20. How do I solve this question? This is a kind of common question in UTME. They can give you a question like this, find the value of x. But remember that I said in this particular question, since we are not given the base is base 10. So how do we move on from here? So there's a particular rule that I need to introduce to you, It's also a logarithm rule. So that rule states that if you have log m base n, I'm only using random variables, so it's not compulsory that it can be n base n, equals to y. This, if I have a scenario like this question can be rewritten as m equals to n raised to the power of y, but there's a proof to it, and we can actually do that. There's a proof to it. But if I have a scenario like this, then I can rewrite this to equate to this. Is understood? So moving on from there, then what I'm going to have would look like this. I'm going to write this first. x raised to the power of 20, then put these values that I have here on the base. That's 10 raised to the power of 20. Remember what we had was log m base n equals to y. So you will write m first, writing x raised to the power 20 first, then equate it to the base, write the base 10, then you put this y on it, put 20 on 10. So moving on from there, this rule is very important, so you need not to forget that. So moving on from there, you observe that what you need is x, and x is in the base, but the power, you need to remove the power. So for this particular question, the powers are common, but there are some questions that will give you that the powers might not be common. So you have to manipulate your way in finding out how to remove your powers and make the base to stand alone. So since the powers are common, I can cut on both sides. So the value of my x is equals to 10. That's the answer to the first question. We have our second question. Our second question states that if x minus 4 is a factor of this polynomial, find the value of this. Now, this is a very simple question. Very, very simple if you are familiar with polynomials. But if you look at this, if you are given a factor of a polynomial and you are asked to find the remainder of the polynomial, what you could do is you substitute the value of this factor inside this polynomial that you get the remainder. But in this particular question, we are not asked to find the remainder. We are asked to find the unknown, the variable in the polynomial. So what we could do is the same, using the same remainder theorem. So we would have that equate x minus 4 equals to 0 first. Then x minus 4 equals to 0 is 4, right? Then since I have x equals to 4, then I would impute s equals to 4 inside this and also equate it to 0. So what I would have is x cubed minus x squared minus 13x plus k. Then I would have x cubed. So that means whatever I see x, I'll impute 4. So I have 4 cubed minus 4 squared minus 13 into 4 plus k. I'm equating it to 0. But let's assume that it was a question under remainder theorem. So this k would have been a constant, a random number. So if that was a number and you are given a factor and they ask you to find the remainder of the polynomial, it's simple. Just use this method, substitute it inside this polynomial, then equate it to 0. You get a, or rather, you get a value. You don't need to equate to 0, you get a value. So what we'll have is 4 raised to the power 3 is 4 times 4 times 4. And you agree with me that that's 64 minus 16 minus, so 4 times this will give us what? 52. That will give us 52 plus k equals to 0. So let's simplify. So we want to do 64 minus 16 minus 52 plus k equals to 0. So our value for that should give us minus 4. 64 minus 16 minus 52 give us minus 4 plus k is equals to 0. So what we are going to have, if we take this to the other side, k is equals to 4. Now remember, the question did not say find the value of k. The question said find the value of this. So that implies that the value of k here, we impute it here to find the value of this particular question. So we have 3k squared plus 2k minus 1. So if we impute 4, we would have 3 into 4 squared plus 2 into 4 minus 1. This is 16, right? And 16 times 3, that should give us 48. 48 plus 2 times 4 is 8. And this here should be minus 1. So this plus this is 56. Our final answer is 55. That's the answer to this particular question. We have our third question. If 1 plus root 5 all over 5 is simplified as this, find the value of this. These are basically simple. It's very, very simple. So what they basically want you to do is this particular question you rationalize in such a way that it looks like this. Then the value that is here, that will be your A, and the value that is beside here will be your B. Then when you get the value of A and B, impute it in this, then you finally solves the question. Now let's go to the question quickly. We have 1 plus root 5 all over root 5. How do we rationalize? So to rationalize, you would multiply this this denominator here. What we have as our denominator is root 5. You multiply by both the numerator and the denominator. So we would have 1 plus root 5 over root 5 multiplied by root 5 over root 5. So the purpose of doing that is to cancel out the root in the denominator. In sod, you don't have roots in the denominator. It's not mathematically correct. So when you open this, root 5 multiplied by this, that will be 5 root 5 into 1 plus root 5. When you close the bracket, you open up, then you have root 5 times root 5. When you open this, you're going to have root 5 times 1 is root 5 plus root 5 times root 5. That's going to give us root 25. You would agree with me that root 25 is 5. So I don't need to write root 25. I can just put 5 all over 5 times root 5 times root 5 is root 25, which is also 5 as well. Is that okay? So we have achieved our purpose. Root is no longer in the denominator. So what do I do next? This answer, I have to look for a way to make it look like this. Then what I can do is I can split the denominator to the two of them. I can say this is root 5 over 5 plus 5 over 5. I've splitted the denominator. So, but I'm not still getting what I want because I need a. So this that I have here, I can write it as 1 over 5 root 5 is this same thing, then plus 5 over 5 there is 1. So that basically implies that a equals to 1 over 5 and then b is equals to 1. So what is now a minus b over 2? That is the question. So what is a? A is 1 over 5 minus 1 over 2. 1 over 5 minus 1, that will give us 1 over 5 minus 1, that will give us what? Minus 4 over 5. So in questions like this in JAMB, you don't need to, they would want to test your speed and accuracy. So you don't need to solve step by step. From even looking at the question, you can solve it, right? So moving on from there, 1 over 5 minus this will give us what? Minus 4 over 5. How do we achieve that? Basically, you would find the LCM between the two denominators. Then 5 in 5 is 1. 1 times this is 1 minus. There's an over 1 here. 1 here, 5. 5 times 1 is 5. Then 1 minus 5 is minus 4. So you have minus 4 over 5. That's why I said the answer there is minus 4 over 5. So you have minus 4 over 5 over 2. If you write this, you're going to have minus 2 over 5 as your answer. Because if you have a scenario like this, you can say 2 here 1, 2 here 2. So that's minus 2 over 5 as our final answer. We have our fourth question. So we are given a matrix question. So we are given a matrix A and as well as a matrix B. And if we consider matrix A, it's a 3 by 3 matrix, as well as matrix B is a 3 by 3. So we are asked to find what is 3A minus 2B. That's very simple as well. So what we do is you would multiply matrix A by 3 and multiply minus 2 by matrix B, and then you're done. Sum them together. So a faster way or a simpler way to do that is you could put it in this way: 3 into minus 1, 0, 1, 4, 5, minus 8, 13, 2, and 0. Then you have minus 2 into B. B is minus 32. 1 minus 7, 1, 0, 17, 9, 6, and 2. Then open the brackets, then you're almost done. So we would have 3 times this is minus 3, 0, 3. We have, this will give us 12. This will give us 15 minus 24, 39, 6, 0. Then minus, open the bracket with 2, we would have minus 64. 2, we have minus 14. Then 2 times 1 is 2, 0, that's 34. This is 18. This here is 12. And this here is 4. So the next thing that we need to do is we have to subtract minus 3 minus 64. So you pick the one in row 1, column 1. You subtract this, row 1, column 1. Row 1, column 2, row 1, column 2, row 1, column 3, row 1, column 3, this minus this minus this minus this, as well as this minus this, right? So we'll write out our final answer. So minus 3 minus 64. Did you see that? Minus 3 minus 64. That will be minus 3 plus 64. What's that? That will give us 61. Is that okay? 0 minus 2. 0 is nothing. So the answer there is what? Minus 2. We have 3 minus 14. That's 3 plus 14. The answer there is 17. We have 2 minus 2. 12 minus 2 is what? 10. Then we have 15 minus 0, 15, minus 24 minus 34. That will give us what? Minus 58. Then 39 minus 18, that's 21. So we have 6 minus 12 minus 6. We have 0 minus this minus 4. So when we are given matrices, we can be asked to sum, multiply, and basically perform arithmetic operations. For in this particular question, we are only asked to subtract, but we needed to first multiply by a coefficient, multiply by a coefficient, then you subtract. So you can do it whichever way you want, but I believe this is like a more faster way. So if you're writing your JAMB exam, you will just first off, when you see the question, what should come to your mind is quickly multiply this, subtract immediately, and then you are racing against speed. So you need to be very, very fast. You don't need to write it all out like this. Is that understood? Next question, we are told that if cos theta is 5 over 13, find the value of, sorry, if cos theta is 5 over 13, find the value of cot square theta. Now, we are given a, let me call it a statement, and that statement will help us to solve this question. So we know that cos theta 5 over 13, that's the only thing that we know. And you remember that from trigonometric function, we would have cot theta. What's the value of cot theta? Cot is 1 over tan. 1 over tan. So I remember that tan theta is opposite over adjacent. Opposite over adjacent. So if we flip this over, 1 over tan theta will give us what? Adjacent over opposite. So cot is adjacent over opposite. Now, so we need the value of adjacent, because in cot, sorry, yes, adjacent over hypotenuse. So basically we need the value of opposite. So we can use Pythagoras theorem to get the missing side of the triangle. So we have opposite square equals to hypotenuse square minus adjacent square. So opposite square should give us 13 square minus 5 square, right? So that should give us 169 minus 25. If we subtract that, that should give us what? 144. So opposite square should give us opposite equals to 12 if we square root both sides. Is that okay? So since we know our opposite, then we can find cot itself. So cot theta is adjacent over opposite. From here we know adjacent as 5 and our opposite as 12. So next we need to find cot square theta minus 2. So cot square theta will give us 5 square over 12 square minus 2. So that should give us 5 square is 25. Then 12 square is 144 minus 2. So if we subtract that, LCM on this part of 144 and 1 should give us 144. 144 here is 1. 1 times 25 is 25. 25 minus 1 in 144 is 144. 144 times 2 is 288. So if we subtract that, we should have minus 263 over 144. So questions like this can come out. You can be told find sec theta. If you are given sin theta, find whatever cot theta, and so on and so forth. For question 6, we are asked to construct a quadratic equation whose roots are minus 2 over 3 and 1 over 4. So basically, you are given the answers to the quadratic equation and you are asked to solve them. So what do? So since you know that the answers to the equation are x equals to minus 2 over 3, and x equals to 1 over 4. Those are the two answers. So what you could do is take them to the other side of the equation, take them to the other side of the variable rather, then bring them together, then you expand, then you have your quadratic equation. So if I bring minus 2 over 3 here, I would have plus 2 over 3. I have my bracket. If I do the same thing to this, I would have x minus 1 over 4, because this is a positive, it comes here, equate this to 0. I can expand this. If I expand this, what would I have? X times x will give me x squared. If I do x times this, I would have x over 4 plus 2 times this will give me what? 2x over 3. Then plus times minus is minus. 2 times 1 is 2. Then 3 times 4 is 12. Equals to 0. So we could find the LCM of everything, the denominators. So if you find the LCM of the denominators, you are going to have 12 as the denominator. So since 12, this does not have a denominator, then 12 is multiplying this to give us what? 12x squared. If you have 4 as the denominator here, so 4 in 12 is 3, right? So it will be 3 times this, that will be what? Minus 3x. Then 3 in 12 is 4. 4 times this 2 give us what? 4 times 2 is what? 8x minus. Then 12 in 12 is 1. Then 1 times 2 is what? 2 equals to 0. So if I divide here by 12, it's still the same thing by just writing like this. Because if I cross multiply, I'll still have 12 times cross multiply 12 times 0 will give me 0. So I can just throw away that. So what I would have here is 12x squared. I have minus 3 plus 8. Minus 3 plus 8 is plus 5x minus 2 equals 0. We have our quadratic equation. We have an indices question for question 7. We are given if 16 raised to the power of 2x plus 3 is equal to 64x minus 2 raised to the power minus 2 x minus 2 over 2 raised to the power x. How do we solve this? Now, I want to give you a bit of a hint. When you see questions similar to this, you see 2, you see 4, you see 16, you see 64, you see 128. Just know that you are reducing everything to the base of 2. But if you say 3, 9, I believe you understand what I mean by this now. 27, 81, I think, right? And so on and so forth. You are reducing them to have the base of 3. So let's explain what that is. So this 16 here, I can write 16 as 2 in 4 places, 2 raised to the power of 4. You have 2 raised to the power of 4 as 16, then repeat the power that was initially there. Then you have equals to 64 is 2 raised to the power of 6. 2 raised to the power of 6 is 64. You have x minus 2, then over 2 raised to the power of x. So moving on from there, you will open the bracket. You have 2 raised to the power of 8x plus 12 equals to this. You can pick one of the common base since it's indices we are doing. Pick one of the common base, that's 2. So since it's division, you subtract the power. You have 6x minus 2 minus, what do we have here? X. So we can cut this on both sides. Then bring the values that you have left, x plus 12 equals to, open this bracket, you have 6x minus 12 minus x. 6 is not multiplying this, it's only multiplying this inside the bracket. So we have 8x plus 12 equals to 5x minus 12. When you take this here, you have 8x minus 5x equals to minus 12 minus 12. So we have 3x equals to minus 24. So therefore, x equals to minus 8. When you divide both sides by 3, you have minus 8 as your answer. This is a very tricky change of subject question. So let's look at it. We are asked to write t in terms of s, u, and a. So when they ask you to write a variable in terms of the other variables, it's basically saying make the first one the subject of the formula. So let's make t the subject of the formula in this particular question. So we have s equals to ut plus half at squared. Now, for some of us that are science students, we are common with this, we are like familiar with this formula. So how do we do this? Let's make it the subject. So first thing first, I have s. I can find the LCM on this my right hand side. So LCM on this side should give me 2. I would have 2ut plus 80 squared. Is that okay? If I cross multiply it, I would have 2ut plus 80 squared equals to 2s, because 2 times s is 2s. What I have here multiplied by this over 1, I have this. Now, if I look at this, it looks like my t is a lot, because if I try to say I want to factorize or factor out t, I'll still have t inside. So there's no way I can do this. So if I rewrite this, you see what I'm about to show you. So you have 80 squared plus 2ut. If I bring these 2s on this side, I would have minus 2s equals to 0. So what does this look like? It looks like this. It looks like this. Ax squared plus bx plus c equals to 0, where t is the unknown that we are looking for. Do you see it? T is an unknown that we are looking for. So that basically means that since we can find variables using quadratic in the quadratic way, we can also use this particular question, solve it through the quadratic way. And the basic method that we can use for this particular question is the formula method, which is given by x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Now, in this particular question, our variable there is not x, our variable is t. So if we have t as our variable that we are looking for, so we need to know our a. Our a in this question is a. A is a. A is A. What about B? B is what? The coefficient of T. That's what? 2U. Then C is what? Minus 2S. So A, B, C, we input it into this formula so that we can make T the subject. T is equals to, would have minus B. Minus B, that's minus 2U plus or minus square root of B square give us what? 4U square minus 4. Then our A. Our A is A as well. And our C is minus 2s all over 2a. So t finally gives us what? Minus 2u plus or minus square root of 4u square plus 8as all over 2a. We have a final answer. In this, t is already standing alone and t is written already in terms of u, a, and s. If p equals x such that x is a member of integers minus 4 less than or equals to x less than or equals to 15, then that's like set A. Then for set Q, we have x such that 2 less than or equals to x less than 10. Then R, we are given the element in the set. So what we do first is list out the elements in P and Q, then try to find what is P union Q intersection R. So writing out what is in P now. So since we are told they are members of integers. Integers range from minus infinity to plus infinity. So we have minus 4 less than equals to less than 15. So basically this is like giving us the range of where we are starting the numbering from, the numbers from, and where we are ending. But since it's less than this and equals to, so that means you are starting from minus 4. It's okay? But if it's only less than, you are starting from minus 3. So for this that is less than or equals to 15, that means you are ending at 15. But if it's only less than 15, you are ending at 14. So to finish that, we would have minus 4, minus 3, minus 2, minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Those are the elements in set P. For set Q, the element is set Q. So for this, you have, that means you're starting from 2 because it's less than or equals to 2. So you're starting from 2, then you are ending at where? Can you think about that? You're ending at where? What is less than 10? That's going to be 9. So you are starting from 2, ending at 9, 2, 4, 5, 6, 7, 8, and 9. So what is Q? Q is 5, sorry, R. Our R is 5, 7, 9, and 13. So we are asked to find P union Q intersection R. So what is P union Q? What is P union Q? P union Q is going to be everything in P because Q is already in P already. So when you join them together, it's definitely going to be everything in P. So you can write P union Q is equals to P. Then you are now asked to find what is P because P union Q is P. So the answer here, you want to use it to intersect R. So you want to do P intersection R. So what is P intersection R? That will be what? What is in P that is also in R? That's going to be what? 5. Check it. 7. What else? 9. And what? 13. So this answer is still the same thing as saying R. So in your option, they might just put P, they can put R, they can put Q. Do you understand? So the answer to this question is still R itself. Because everything in Q is in P. Also, everything in R is in P. Number 10, which is the last question for this particular video. So our question is, if the first term and the common difference of an AP are minus 2 and 3 respectively, so find the sum of the first 20 terms. That's simple. So first thing you write out is, A, first term is minus 2 and common difference is 3. So when you hear the word respectively, the first person here will take this value, the second thing you'll take this second value. That's why A is minus 2, D is 3. And we have to find the sum of the first 20 terms. So first thing that we need to note is an arithmetic progression. So for the sum of them of an arithmetic progression, we have this beautiful formula, n over 2 into 2a plus n minus 1d. So S20 will give us 20 over 2. That is sum of the first 20 terms. Then our first term is minus 2. Our number of terms that we're looking for is 20 minus 1. Then the common difference, 3. So if you simplify, you have 10 into minus 4 plus 19 plus 3. So you'd have 10 into minus 4. So you'd have 3 times 19. What should I give us? 19 times 3, 7. 3 here, that's 57. So we'd have 57. So minus 4 plus 57, that should give us 53. We'd have 10 into 53. S20 equals to 530. So we have come to the end of this particular video. In the consecutive video, we'll be doing the remaining 90 questions. So endeavor to give a like and as well subscribe to this YouTube channel so that you can be aware when we release other videos in the coming sessions.